Agents for Amazon Bedrock tutorial. Given a prompt in natural language, Amazon Bedrock Agent can figure out steps to be taken and perform actions using enterprise data and systems. It is made up of foundation model, action groups, and knowledge bases. The model is invoked to understand user requests. Action groups define the actions that can be taken. They are defined by an open API schema and a Lambda function. Knowledge base contains data that can be queried for additional context to augment the generation of responses. The data is stored in a vector database, and the agent orchestrates all of this. Here's the overall Bedrock agent flow. Before we jump to the tutorial, let's understand this. First, the agent contextualizes user input and asks the foundation model to categorize and validate it to ensure that it is not malicious. If found valid, an orchestration prompt is created with user input, conversation history, metadata about available actions, knowledge bases, and instructions, which is passed on to the foundation model. The response has suggestions for next steps. And if there are measures to be taken, like invoking a Lambda function or querying the knowledge base, they are executed. Action groups are where actions are defined, which are implemented as Lambda functions and described using a corresponding open API schema. Knowledge bases store enterprise data as vector embeddings in a vector database, allowing for efficient search and retrieval of information, which is then used to augment the generation process. So after invoking action group and summarizing results from knowledge base, the agent generates an output called observation, which is used to augment the base prompt that is then passed on to the foundation model. Upon parsing the response, agent determines if it needs to repeat the orchestration process. This loop continues until agent is ready with a final response or it needs to ask the user for additional information. The pre-processing prompt, orchestration prompt, and knowledge base response generation prompt are all generated from templates, which can be modified by you to fine-tune agent behavior. Our fictitious Bytes Commerce company maintains a product catalog and its corresponding inventory. We want to build a Bedrock agent that can answer questions about products, inventory, and take actions like restocking products in case of low inventory. We are in AWS Console, Amazon Bedrock section. Under Orchestration, select Agents. Click on Create Agent. Provide an agent name. That will be Agent Bytes Commerce. Leave everything else as default. Hit Next. Select a model to work with. And then provide instructions for the agent. You are a helpful agent that can answer questions related to product catalog and inventory. Hit Next. Now you can add an action group. We will do this later. So scroll down and hit Next. Here you can set up a knowledge base. Again, we will do this later. So hit Next. Review the agent details and create agent. Our agent has been created. On our agent details page, if we scroll down, there is a working draft. So let's click on that and open it. Here we can see that there are no action groups or knowledge bases yet. We can test the agent in its current state. Let's do that. What are the products in our product catalog? And the response is, sorry, I don't have enough information to answer that. And that is on expected lines. Next, we will create a knowledge base. Setting up a knowledge base involves creating a data source S3 bucket, selecting an embedding model, and a vector store. The bucket is where our enterprise data is kept. In this case, our CSV and PDF files. The embedding model converts text to vector embeddings. Remember that embedding model is different from a foundation model. We are in S3 create bucket section. Provide a bucket name, bytes commas -kb. Hit create bucket. Our bucket has been created. Let's upload our files. We have a PDF and a CSV file, product catalog.csv and product descriptions.pdf. Upload. Let's examine these files. Product catalog.csv has product ID, product name, type, color, weight, size, company, and price. And product descriptions.pdf has product ID, product name, and description. Choose the knowledge base menu under Orchestration and hit Create Knowledge Base. Provide a knowledge base name. Leave everything else as default here and hit Next. Provide a knowledge base data source name and then an S3 URI. This is the URI to the bucket we had created earlier. Hit Next and select an embeddings model. Okay. Scroll down and select a vector database. Here we will go with the first option of OpenSearch serverless. Hit Next. Review all the details. Hit Create Knowledge Base. And knowledge base creation takes some time. So our knowledge base has been created. Now we need to perform the sync operation for the data source in the knowledge base. So select that and hit sync. During this operation, the text is read from the source S3 bucket, converted into vector embeddings and ingested into the vector store. So this is done. During knowledge base creation, we had selected OpenSearch serverless vector store as our vector database. Let's take a look at it. In AWS console, OpenSearch section, under serverless, click on dashboard and you will see the serverless dashboard. Here under collections, you will see a collection that was automatically created during the knowledge base creation. And here you can see that the collection type is vector search. It is a default collection created by Amazon Bedrock knowledge base, and under indexes you will find a corresponding index. Our knowledge base is ready and we can add it to the agent now. To add knowledge base to the agent, we go to the agent details screen and open the working draft. Here under knowledge bases, hit the add button and select the knowledge base we had created earlier and then provide a instruction. The knowledge base has list of products, their attributes and descriptions. In product catalog, each product has attributes so and so. Hit add. This takes some time and our knowledge base has been successfully created. Let's test the agent in its current state. Hit the prepare button and then Click on Test. Provide a prompt. What are the products available in our product catalog? Waiting for the response, and there we have it, list of products along with a source reference. Response from an agent comes with a trace that allows you to review the steps being orchestrated by the agent. You can track the path taken to arrive at the current response. When you click Show Trace, you are presented a screen with multiple tabs like pre-processing and orchestration with various trace steps. Here you can go over agent's reasoning and orchestration plan. This helps you troubleshoot orchestration issues and steer the model towards desired behavior by adjusting instructions. Therefore, this visibility into the model's reasoning helps you understand how agent is functioning and taking steps. If you are wondering how does the foundation model come up with an action plan and a rationale, the prompts have instructions and a lot of contextual information like conversation history, available actions and knowledge bases, which helps the foundation model reason and provide a suitable response. The prompts themselves are generated from prompt templates. So, the pre-processing prompt, orchestration prompt, and knowledge base response generation prompt are all generated from prompt templates. Let's take a look at these templates. As a beginner user, you probably don't want to modify them, but it's always good to know that you could if needed. Under Agent Details Working Draft, you will find Advanced Prompts. Advanced prompts are a set of system-generated instructions. Here you will find prompt templates for pre-processing, orchestration, knowledge-based response generation, and post-processing. The pre-processing template determines if a user input should be passed on for orchestration. You can edit this template if necessary. There are placeholders for functions, conversation history, and so on. And on the right hand side, there are configurations for randomness and diversity, things like temperature, top P and top K. The orchestration template defines the order in which actions are executed. And the knowledge base response generation template defines how knowledge bases will be used in the response. Another prompt: does the company Nova Dynamics have any silver colored products? Let's see if the agent can answer this. Hit run. And the response is Nova Dynamics makes the silver colored Silver Surge laptop. Let's verify this against the data we have. So here you can see Nova Dynamics has a silver colored Silver Surge laptop. Next, we will create an action group which uses a Lambda function and a corresponding open API schema. In AWS console under Lambda functions, hit create function, provide a function name, bytes commas function, choose a runtime, Python, scroll down and hit create function. So our function has been created. Now let's go to the code section. We will paste our code here. Here we first get the API path, and if the API path is get products inventory, we return the inventory which is product ID, product name and quantity. We would ideally be getting this data from a database, but here we have hard coded the response. And similarly, in case of restock product, you might actually want to create an order, but in this case we simply return a success response. Hit deploy. Go to the configuration tab and then scroll down. Under resource-based policy statements, hit Add Permission. Select AWS Service. Choose Other. Provide a statement ID. Our principal is bedrock.amazonaws.com. And here we need to provide ARN of the agent. So we go to the agent details screen and copy the agent ARN. And then return here and paste that ARN. And then choose Lambda invoke function for action. Hit save. To add action group, go to the agent details screen and open the working draft. And here against the action groups, hit add. Provide a action group name. And then select the Lambda function we had created earlier. So that's bytes commerce function. And for select API schema, choose the define with inline open API schema editor. And here we have pasted our schema. Right? So under paths, you can see get products inventory. Okay, so it returns an array of items with these properties: product ID, product name, and quantity. And then for the API path restock product, here it takes product ID and quantity as inputs and returns status as a response. Now remember that our Lambda function is implemented as per this schema. Hit add. Now that we have action groups and knowledge bases set up, we can test the agent. Hit prepare and then click on test. Our prompt: get all product inventory. Waiting for the response. And the message is, sorry, I tried calling the function to get all product inventory, but it returned an error saying unknown API path. So let's go to the log groups under CloudWatch for this function. And under log events, take a look at received event. Here you will find the API path, get products inventory. Now we will go to the Lambda function and check this. So there is a small mistake here. They should be get products inventory. The S was missing. Okay, we correct that and hit deploy. And then back to testing. Our prompt: get all product inventory. And this time we get the inventory of products. You can see there is a product ID, product name, and quantity. So for product ID P002, you can see that the quantity is 0. Let's restock that. Restock product ID P002. Okay, so there is a question: how much quantity would you like to restock for the product? 200. I have successfully created a restock order for 200. An agent alias is a pointer to a specific version or snapshot of an agent. In agent details page, hit create alias, provide an alias name, agent alias bytes commas, and then click create alias. So our alias has been successfully created, and you can see that alias has been created along with the version. You can test agent alias just like you would test a working draft. So that was the Amazon Bedrock Agent tutorial.